Hello and welcome to the first lecture for the Algebra Foundations. So, what is algebra? So, algebra is the branch of mathematics in where letters and symbols are used to represent numbers. These letters and symbols are referred to as variables. Very important. So, clearly, you'll be dealing with lots of problems dealing with variables, so it is important to understand the foundational concepts of algebra. Before we begin talking about how to simplify algebraic expressions, let's go ahead and quickly review some terms you need to be familiar with. Not you need to be, but rather you must be familiar with. So let's move on to the next slide. So here's a chart with some very common terms. Chances are you already know these terms, but this is going to be, of course, a video where I cover these terms. These are very important. So the first one is variables. What is a variable? Well, a variable is any letter that represents a number. Now, we don't know what this variable represents, but if we are given an equation, we can go ahead and solve for that variable. So, for example, I have here X or Y or even capital P. These all can represent a variable. So if I were to simply have the equation 5x minus 2 is equal to 3, how do I solve? I have to solve for that variable, which is x. Well, you have to know the basic rules of solving a algebraic equation, and if you don't know that, that's fine. We're going to cover that in a later video in the algebra section. So what we want to do is we want to isolate the variable. So in this case, we're going to do the opposite of minus 2, which is plus 2 to get rid of this. So on the right side, I have 5, and on the left side, I have 5x. And now I want to have x by itself, so I can divide both sides by 5, and x is equal to 5 over 5, and 5 over 5 is just 1. So x is equal to 1. So x is called the variable in this case. Now, you can also use symbols to represent variables. So in this case, if I had 5 star, actually, that is a poorly drawn star, but if I had something like 5 star plus 3 is equal to 7, the question can ask you, solve for the star. So essentially the same exact thing, right? This star here is the variable. Okay, the next thing we're going to learn is what the coefficient is. What is a coefficient? So any number in front of the variable is called the coefficient. So the number in front of the variable, so in this case, if I have the term 7x, the coefficient here is 7. How about 82y? So the variable here is a y, and the coefficient is going to be 82. How about 0.1x? 0.1 in this case would be the coefficient. Now here's something important that you should know. How about z, just the variable itself, or just x? What is the coefficient in this case? And this is very important. You must know this to help you understand some harder practice examples when we go on. The coefficient for these terms is always just 1, because 1 times z is simply z. 1 times x is simply x. 1 times anything is simply that number. So we can always use a 1 as our coefficient when we just have a variable here in this case. Okay, moving on to the next term, which is like terms. So what exactly is like terms? You must be familiar with this, especially when we're dealing with simplifying algebraic expressions. So in this case, you'll notice that 3x and 2x are like terms because they include the variables x. How about 5yz and 8yz? Exactly the same thing. They are like terms because they include the variables y and z. How about 0.5b and 9b? Yes, once again, they're like terms because they both have b. How about if I wrote this? What if I said 5yz and 8zy? Now, this is very important. These are also like terms. Why? Because, remember, all you're doing is you're just multiplying these variables. This is 5 times y times z. And if you remember the commutative property of multiplication, this is the same exact thing. I can rewrite this as what? I can rewrite this as 5 times z times y. It doesn't really matter in which order I put it. I can even write it as y times z times 5. It really doesn't matter. Of course, the conventional way would be to put the coefficient first, the number first in this case, which is 5. So you would typically see it as 5zy or 5yz. Same exact thing. So these are like terms. So that's very important. How about expressions? Now, the difference between an expression and an equation is simply that expressions do not have equal signs. Easy as that. Simple as that. Expressions can be 7x plus 2, 9y plus x minus z, 3x minus 2 plus 7y plus 99 x. It doesn't really matter. These are expressions. Equations are whenever you have an equal sign, so you can go ahead and actually solve for the variable that you're given. Now, how about a monomial versus a binomial term? Mono meaning one. This is a singular term, so the number 87 itself, it's just a single term over here. Y, I'm just giving you 3 different examples here. This is a single term. 9z squared would be a single term. 5yz cubed would be a single term as well. A binomial, on the other hand, is when you have 2 terms. So it's x plus 3, or x to the 5th plus y to the 7th, or y minus 3. And so on and so on and so on. And these are going to be very important. Please know these terms, be familiar with these terms. Obviously, a trinomial would be 3 terms, so it would be something like x plus 3 minus y. This over here would be a trinomial. And of course, a polynomial is an expression that has more than 2 terms. So you can have 7 terms, 6 terms, or even 3 terms. A trinomial, of course, is also a polynomial. Now, the last term we're going to review in this slide over here is going to be the terms linear versus quadratic. So in this case, we have a linear expression given here, which is just 5x. When we go into coordinate geometry and talk more about linear equations and quadratic equations, you'll see, and for now, all I want you to know is that linear equations, whenever we graph a linear equation, so if I were to graph 5x, on the graph, it's going to be a straight line. So this straight line obviously will be at an angle, but it's always going to be a straight line, hence the word linear. And quadratic is where you have a term that's going to be raised to the 2nd power. So all quadratic expressions must contain a term that is raised to the 2nd power. So in this case, I have 3x squared, making this a quadratic term. And of course, in the next 2 or 3 videos, we're going to be talking about quadratic equations, and you'll notice that all quadratic equations have a term where this variable, in this case x, is going to be raised to the 2nd power. Not the 3rd power, not the 4th power, but the 2nd power. And of course, if you were to graph this quadratic term, you will get a parabola, but we're going to talk about that much more into detail when we go into coordinate geometry, which is all the way at the end of the foundational videos for algebra. So these are terms you should be familiar with. Let's go on and move on to the last slide. We're going to be talking about how to translate basic algebraic phrases into expressions. Alright, so in algebra, you must be able to translate phrases into an expression or equation. Let's do a few easy ones, and as we move on to learning more concepts, we will introduce word problems. Now, word problems is going to be a very important topic. You will see lots of word problems on your exam, and this is just the elementary step. So right now we're just dealing with phrases, but word problems are far more complicated. You are given various information, and you are going to be required to know how to translate all the information given into an equation. So before we move on to the hard stuff, let's go on and let's take stepping stones, and this is the first stepping stones, is to understand how to translate basic phrases into an expression. So what do we have over here? Our first statement reads, the sum of 1/3 of x, 2/3 of y, and 2. So how do you approach this? You must look for keywords. The keywords here are the words sum and the words of, and if you recall, we covered the key term of back in arithmetic when we talked about percentages. Of means to multiply. So think about that again. The sum, so sum means to add. The sum of 1/3 of x, so let's write that down. So 1/3 of x, so 1/3 of x means just 1/3 times x, so I could just write it as that. So 1/3 of x 2/3 of y, so 2/3 of means to multiply, so I can just leave it as this, so 2/3 of y, and 2. So let's reread this one last time. The sum, that means that we are adding all of these terms. The sum of 1/3 of x plus 2/3 of y and 2. There you go. This is how you write the expression for this statement over here. Let's go ahead and take a look at the next one. We have 2/5 of the sum of 5 and x. So 2/5 of means to multiply the sum of 5 and x. So 5 and x are being added together, but I'm going to multiply that with 2 over 5. So I can use parentheses to represent that. So now this represents this statement over here, which is 2/5 of the sum of 5 and x. The next thing looks fairly easy, but there's a reason why I put this, 5 less than y. What some students will do is they'll make the common mistake and say, okay, well, 5 less than y, that's easy. 5 less than means subtract, and y, boom, we're done. No, that is wrong. This is not correct. Please do not make this mistake. Not many students make this mistake, but this is a common error that some students will make if they don't understand this or if they do it too quickly. Take a look at this statement carefully. It says 5 less than the term y, right? Meaning it's the other way around. It's y minus 5. What if I were to write, instead of 5 less than y, what if I said 5 less than 10? Well, how do you think about that? 5 less than the number 10, which is just 10 minus 5, which is equal to 5. So same thing here when we're dealing with a variable here, 5 less than the variable y, so that's y minus 5. So it's very important to be able to translate these phrases properly. The last one here is 7 times the sum of x. This one is straightforward. So the sum of x and 2 is just x plus 2. And if we're going to times that by 7, I can just put this in parentheses and put 7. So this now translates properly to this phrase over here. So hopefully now, by the end of this lecture, you understand how to translate basic phrases into an expression, and you also know the common terms in algebra that we are going to be dealing with from here on and out.
Check out our website at www.argoprep.com to access our full online GRE platform where you can access over 20 hours of video lectures, 500 plus practice questions, and 7 full-length practice tests.